Okay, so today is our first day of doing what we call hydrolysis of salt problems or hydrolysis problems. It's the third thing we have to be able to find the pH of a salt solution. So we have strong acids. How do we find the pH of strong acids or bases? Negative log of their concentration, right? Thank you. How do I find the, okay, I'm sorry, people at home, I'm getting things. Isabella and Chloe, apparently y'all have to go immediately. Sorry, but it says quick, so here, give it to her. So y'all just need to, I guess, watch this video if you miss things. So how do you find the pH of weak acids and bases? What do we do? Take the acid or base, add it to water, put it in a rice table, right? Well, now we're going to do salt solution. So the hardest part about this is literally the first step. Identifying it's a salt, knowing how to write the reaction in order to get the rice table started. So you did this at the Chem 1 level. You found pH of salts like this, but you didn't find the exact pH. You found whether or not the salt was acidic or basic or neutral. So we're going to review that part. This is what I call the baby way of doing it. So you started out looking at a salt like this, right? We know that all salts are made from two parents. What makes salts? No. Think of a reaction that always makes salt and water. Right. So what are we adding in a neutralization reaction? And an acid and a base. So all salts have an acidic parent and a basic parent. So to figure out what kind of pH these salts are going to produce in the solution, we look at the parents. What parent base does this come from? NaOH. And what parent acid does this come from? HCl. So if we compare the strengths of these guys, we can then figure out at least the range of the pH. What strength is sodium hydroxide? What about HCl? So if they're both strong, we're going to have a pH of 7. Okay? Because they kind of fight each other and neutralize each other out. Now, if we have something like ammonium nitrate, what base does this come from? Ammonia. Some people said ammonium hydroxide, which is for all intents and purposes the same thing. And what acid? Nitric acid. So classify this base. Weak. Classify the acid. Strong. So what is the range of the pH? Yeah, it's going to be acidic. So it's going to be less than 7 because the strong parent basically wins. And then finally we could do like, sodium carbonate or something like that. What is my parent base? Parent acid? We have a strong base and a weak acid. So what's this one's pH range? Greater than 7 because we're basic. So do we get that? That was what we did in Chem 1. Now, however, you're going to have to actually calculate what the pH is and basically figure out, well, why are they becoming acidic or basic? What's happening in the solution? So I'm just going to inject a blank slide here. You guys can kind of take notes. All the preceding slides that we have, you guys have as notes in your packets that you can read on your own, all right? So you can read those when you're studying. What I want to do, though, is just kind of jump in and explain it kind of organically. So starting out, I want to look at that sodium bicarbonate salt. We said that that's going to be basic. So I need to be able to see in solution what's exactly happening that's making this basic. So if we have this salt starting out as a solid and we dump it in water, what's the very first thing that happens to it? It's going to ionize. It's going to dissociate. So we can write a dissociation equation. It's important that you guys understand the difference between a dissociation equation and an ionization equation versus something like a hydrolysis reaction, okay? So if we dissociate this into its ions, it hits the water, it makes 2Na plus CO3 minus 2. So now what's going to make this thing have pH, this solution have pH, is the potential reaction of those ions with the water itself. If we take sodium, we know sodium came from a strong parent, right? So we know sodium is always a spectator, right? Sodium never, ever, ever will make precipitates, will never do anything. So when you add this to water, what ultimately you're going to do is you're going to make sodium hydroxide, which is strong, which is pretty much having sodium plus on this side, so nothing happens. So whenever the ion that came from the strong parent tries to react with water, it won't. It's just going to sit there. So this does not undergo hydrolysis. Okay? But if you take the ion from the weak parent, in this case, that carbonate ion, and we put it in water, it does react with water in an equilibrium situation where we have the Laurie-Bronsted stuff going on. So what is, remember, these acids are stepwise, so we might ultimately get 2 H's added on there, but we just move one at a time. And so what do we make? HCO3 minus and OH minus. Oh, we made OH minus. What was our prediction about this one? We said this one was going to be basic, right? That is what's making it basic, right there. The production of that OH minus. So, doing a little synopsis of this, if you have a salt that is dissolved in water, only one of the ions is going to undergo hydrolysis because we're not going to have weak parents. That doesn't happen at this level of class. One of the ions is going to undergo hydrolysis. It's going to react, and it's always the ion that came from the weak parent. This is what we start our rice tables with. Okay? That's the hard part. Once you've done this, it's all, you know exactly what's going on. Okay? So let's jump into, go to that number 12. Predict the products when KCN is added to water. Will the pH of the solution formed when the salt is added be greater or less than 7? Let's do our prediction from the baby way. What do we predict this pH range to be? What are the parents? We have KOH, and what's the acid? HCN, right? So that dissociates into 2 ions. What's our prediction? High pH. It's going to be potassium hydroxide parent, which is a strong one. So this should have a pH greater than 7. That is no longer an acceptable way to do it. Okay? That has really, honestly, there's no true proof here that that's happening. The proof is in the actual reaction. So KCN, for a while, if you need to write the ions that this dissociates to before you start your hydrolysis reaction, that's fine. Look at the 2 ions. Which one came from the weak parent? CN minus. K plus, if we add it to water, it's not going to do anything. It's just going to hang out as K plus. But the cyanide ion is going to undergo hydrolysis, and what are we going to make? Hydrocyanic acid and OH minus. Is it basic? Yeah, this is why it's basic. Are you getting it? Okay. Write the dissociation equation that describes what happens when methylamine chloride is added to water. So my question will be, is that a weak acid or base? Methylamine chloride? Is that a strong acid or base? No, it's a salt. When you have 2 ions like that, it's a salt. So that falls under 3, okay? So What happens when it's added to water? It says dissociation equation. They've been putting that on the AP quite a bit, and students are expected to, I want you to know the difference between dissociation and actual hydrolysis. So CH3, NH3Cl, when that is hitting the water, it dissociates to what? What? Plus Cl minus. In dissociation equations, you've got to see the ions. They won't take it without the ions. So now, write the equation which describes the acidic character of the CH3NH3. They're nice here. They're telling you which one came from the weak parent. Go ahead and cross out the equilibrium expression. We're not going to do that just yet. Okay. Write an equation which describes the acidic character of CH3NH3+. So that came from the weak parent. So we're going to take that and we're going to add it to water. It's saying it's acidic. It's telling you it's acidic. It's got acidic character. So it's telling you that's an acid, which is a what? A proton donor. So what are we going to make? CH3NH2 plus H3O plus. That has produced an acid in solution. Does that jive with the baby way? This came from a weak base. That came from a strong acid, right? So it should be acidic. Okay, so let's jump into how these problems will be presented to you on the AP. Calculate the pH of a 0.7 molar sodium acetate solution, and they give you the Ka of acetic acid, which you will need. I'm always going to be saying this. Let's classify it. Is sodium acetate a strong acid or base? No. Is it a weak acid or base? No. Is it a salt? Yes. So it's a hydrolysis problem. So what two ions? If you don't write the dissociation equation, at minimum, kind of do this just so you could clear your head. Because you're not going to ever, I have students who will take the whole sodium acetate and shove it in the rice table. No. Remember, when the salt hits the water, it dissociates into these two ions, and those are the things that undergo hydrolysis if they can. So we start our rice table by reacting the one from the weaker parent, which is, C2H3O2 minus is added to water. So we're in equilibrium. Which way does the H have to go? To the acetate. So what do we make? Acetic acid. And the other ion is hydroxide. That's the hardest part. Now that we have that, we can go, okay, my original concentration of the acetate, because for every one sodium acetate, there's one acetate, 0.700, cross out the water, 0, 0, minus X, plus X, plus X. So we get 0.7 minus X. I can trump this, X and X. Okay, this is the next thing that's different, and it's very specific only to hydrolysis problems. When we write the expression, I need you to pay. This is another reason when we're yelling at y'all, write your expression, because of this. If you notice, our expression, our K thing here, will start with an OH minus on top, divided by, your typical setup. But the situation is that this is an OH. So do we need a Ka or a Kb? We need a Kb. Look what they gave us, those jerks. What did they give you? Ka. What they gave us was Ka for acetic acid, not Kb for the conjugate, which is what we really need. So we have to calculate Ka. There is a relationship, just as if there's a relationship between the pH and the pOH, there is a relationship between Ka and Kb. Can anyone take a wild guess? If I have pH plus pOH, I get what? 14. If I have Ka and Kb and do something to them, I might get, no, Kw, 1e negative 14th. So what I need to do, and I'm going to write it up here. We know that Kw is Ka times Kb. So what I'm going to do is I like to solve, if you really want to, you can solve on the side, put in 1e negative 14, put in the Ka and solve for the Kb. I kind of like to just take my Kw and divide it by what I'm looking for and actually just insert it in my equation. So this is what I'm going to do. I'm going to do 1 times 10 to the negative 14th divided by the Ka of 1.8 times 10 to the negative 5th. That is equal to x squared over 0.7. You don't have to do this, but as a grader, I really like this. It's showing me you know you did the conversion, and mathematically, it's going to be quicker for you. But if you prefer, like I said, and want to do Kb on the other side, you can. So x is equal to, again, I need to see what x is equaling to because that's going to be what's allowing us to solve for the pH. Don't worry about sig figs on this. This is not a final answer. What is the concentration of OH minus, please? I need multiple answers here. Make sure we get the right one for the video. 1.97 times 10 to the negative 5th. A lot of you on the test that you're going to get back today did not put units in this situation. You got a point off. Your x has units. All right, so how do I find the pH? I got a couple things I got to do. Okay, by taking negative log of OH minus, I get POH. So what is POH's value to, let's look at sig figs, the constants to, let's go with 2 decimal places. 4.71, everyone agree with that? And then, are we done? No, they're asking us for pH. And it makes sense because this is supposed to be basic, right? So we need a pH that's higher than 7 here. What do we get? 9 point what? 9.29, and that is our pH. You guys doing okay? Not too bad? All right. We're going to get some more problems here. Couple things we need to do. I'm going to do A, B, and then C is really not a calculation. Couple things we need to do in both these situations is to find the K value. Normally, they're going to be given to you in the problem, so don't worry too much about it. But there is a table in the back of your packet, and I want you to look for a reason. If you look, are you going to find, what are the 2 ions we're dealing with here? K plus and ClO minus. Which one comes from the weak parent? The ClO minus. Are you going to find anything on that table for ClO minus? No. You're probably going to find the Ka for HClO, and that's what I want you to look for. What is the Ka in this problem? I know it's on there. They gave it to me last period. It's at the end of the packet. The Ka for HClO is do y'all not have your full packet? 3.5 times 10 to the negative 8. That's the Ka for HClO, so we need that to complete the problem. For the next problem as well, we're not going to find the Ka for ammonium, but we will find the Kb for ammonia, which is 1.8 times 10 to the negative 5th. All right, so let's go ahead and start that first problem. We know what 2 ions we split up to. We know that's a salt, so it's a hydrolysis. What are we going to hydrolyze? What undergoes hydrolysis? Which ion? ClO minus. We're going to add water to it. And what are we going to make? I'm getting the usual suspects talking. I need to know, do you understand this? Do you understand how to move H's? Because not one of you is responding to me except the same people over and over again. Moving an H is crucial. Do we all get it? So our initial concentration here is 0.355, 0, 0. Minus X, plus X, plus X. We get 0.355 minus X. X and X, we can trump the X. Don't worry about for salt problems. I mean, technically we're supposed to find percent dissociation, but I'm not hyper concerned about it. I need you to have that 5% rule in your head, and when you're asked about it, and specifically to find it, you need to be able to know how to find it. That's in the last video. Okay, so we need to write our expression. What kind of expression are we going to write? A Kb is equal to HClO OH minus divided by ClO minus. Did they give us a Kb? No, they gave us a Ka, so we have to do 1 times 10 to the negative 14th divided by 3.5 times 10 to the negative 8th, and that's equal to X squared over 0.355. So my X, again, I have to see that that is equal to the OH concentration is what? Don't forget to take the square root. Matthew, what'd you get? Can I get a second on that? Okay, so this is the concentration in moles per liter. Now if I take the negative log of that, let's go ahead and give me 2 sig figs or 2 decimal places in the POH, I get 3.50. Therefore, my pH is that wrong? Oh, I thought you said that was wrong. Okay, 10.50. And it's basic, which makes sense. Okay, let's do one more. Do y'all have any questions on it? I need to change this color. It's still depressing me. All right. We identify that as a salt because we've got 2 ions in it. And this will dissociate into what 2 ions in water? Ammonium and chloride ion. Which one undergoes hydrolysis? The ammonium. So we're going to do a rice table. We're going to take the ammonium and add water. So what are we going to do? Which way does the H have to go? Yeah, from the ammonium, because it's already positive, to the water. So we make H3O plus NH3. Guys, zero sympathy if you don't have your charges on there. They're not optional. Okay? So 0.777, 0, and 0. Shift to the right, minus X, plus X, plus X, 0.777 minus X, X, and X. So we're ready for our expression. What kind of expression do we have to write? Ka is equal to H3O plus times ammonia divided by ammonium. Do I have a Ka? Nope. They gave me the Kb of ammonia, not the Ka of the conjugate, so I'm going to do 1.8 times 10 to the negative 5th divided by, oops, sorry, my bad, 1 point, can I move it? 1.0 times 10 to the negative 14th divided by that is equal to X squared over 0.777 X, which is equal to the concentration of H plus this time is what y'all get? 2.08 times 10 to the negative fifth moles per liter. And then if I take the negative log of that to 2 sig figs, aka 2 decimals, what is my pH? We're expecting acidic, right? 4.68. Everyone agree with that number? All right. So that's how you do them. If you get to a problem like the next one, which is really not a calculation, because what's going on with that guy? What 2 ions do we make? What can you tell me about that? Neither of those undergo hydrolysis, right? So since they don't go under hydrolysis, what would the pH be? pH would be 7. And that would be your answer. Neither ion undergoes hydrolysis. And again, you'll never have a weak. It's possible. You could have, you know, an ammonium carbonate, but to do those, it would basically double the work, and then you have to like total up your final OH concentration or your final H. It's just, they're just way more complex than this course is requiring. So there'll always only be one that undergoes hydrolysis. Okay? All right, that's it for the video.